one thing. I'll take a radioactive substance here. There's a uranium-238, best example. Then, so from here, what I see that I'll get a particles. So this particular particles, what I get, I'll call alpha. Then beta, and next there's a gamma particle. So what is the alpha particle? Alpha particle consists of 2 protons and 2 neutrons. Simultaneously, like it's not like they combine outside. From the inside the nucleus only, this alpha particle will emerge out. Then what about beta? Again, we do have two things. This alpha positive particle. No? Again, the beta we have beta plus, beta minus. So what is a beta plus? Positron. Beta minus, electron. And gamma is what? A photon. When I go for this, how do you can, why you are showing like this? So what I do is I'll keep a magnetic field, because the ejected particle will have velocity, and if there is a magnetic field, external magnetic field is there here. So you go back to the b bar into the plane velocity. So positive charge particle will deflect upward, negative charge particles will deflect downward, and those which are neutral, so what happened to them? They just move undeflected here. So how do you come to know that it's undeflected? I will take some target here. I'll keep it here. When this photon, it's a gamma photon. I'll keep some screen, phosphorus screen. So when this gamma photon goes and strikes, fluorescence, I'll get it. This all no. The fluorescence will get the gamma photon. So when I measure this, the path, the different particles here, like alpha and beta, they're having different radii. So they show that they might have different charge and mass. So like this, I'll measure it. So when I keep magnetic field, transverse magnetic field, when I introduce here, I'll see the particles get deflected like this. So I'll measure the radius. From that, I'll measure the mass and charge. So what do I notice? That alpha particle. What is the beta particle? One proton it is. Sorry, beta, it's an electron, that one, positron. So what is the positron? Charge of electron, but positive charge. Magnitude will be 1.6 in 10 power of minus 20, will be positive. And electrons will be emitted here. So like this, I'll confirm alpha, beta particles will be emitted, and gamma. So gamma is not a particle, still we'll call it. It's a photon. So why do that alpha particle will come? So if you look at the nucleus, which is unstable, this is A, this is A. So 2 protons, so it will become daughter nucleus. There's a parent. It become a daughter nucleus. So 2 protons, and the mass number should decrease by 4, and we'll get alpha particle plus some energy released. What is this? This alpha particle. And this is what? Energy release. And this is a daughter nucleus. Newly formed daughter. This is the unstable parent nucleus. Let's come to the collisions concept later on, because let me introduce you to the radioactivity, because a pure mathematical one. We'll finish off that. Then together all the reactions will put at one place. There'll be a better idea, rather than here again I'll discuss theory, then I have to go for physics collision, then coming back. At a stretch, we'll enter radioactivity, we'll finish off, then we'll come out, then we'll be focusing only on what? The physics concepts clearly. This is what alpha decay. And next we have a beta decay. In a beta decay, there are 2 types of beta decay. The energy release also I'll tell you later on, because it will not help you much here. There are 2 beta decays are there. One, beta minus decay. So inside an electron should be ejected, no? If the electron ejected means the mass number will not change. An electron, so what happened to charge of a proton will increase and will get a one beta particle on this -1 0 you can put it, and some energy released here. So this is what beta minus. If you're getting confusion, I'll write it beta minus, or nothing but it's an electron. Beta plus number of nucleons, what happen, will remain same. And plus Q, that one. So this was the beta decay. Decay I'm using, this is the alpha decay. We'll discuss in detail. And what about the gamma? Why that gamma will come? Gamma is not a decay, so therefore let me not touch it. Still we'll call it say gamma decay. Gamma decay, when it will happen? After alpha or beta decay, if the nucleus, the daughter nucleus, if it is not in a like a ground state, if it is an excited state, to come to ground state, what happens? It will give out a photon. That is what gamma photon. So we don't get gamma independently. Only after alpha or beta decay may happen. After alpha and beta decay may happen, that one. So this everything what happen will come under the decay process. So here afterwards, the radioactive decay means either it can be alpha, beta, but not gamma. Gamma will not come under the radioactive decay. That one still we write it gamma decay, because after alpha decay we see that the daughter nucleus formed. If it is in ground state, we don't get gamma decay. If it is in excited state, again this nucleus orbital should jump to ground state, then give out the gamma photon. So here after decay means alpha and beta. So who will undergo decay? Not iron, not copper, because they're stable, they're middleweight, they're stable. Those which are having binding energy per nucleon less than 8 or around 7.5, they're unstable. To attain stability, what happens? They decrease the number of nucleons. And they don't emit one neutron, one proton. Either it should be alpha particle or positron or electron. It's what they can eject. That's about the nuclear decay process, what we call it. Again, K capture is the electron K capture. That will put everything, I'll bring in the reaction, because here, what is our physics? We should calculate this energy released. We have to write equation, how that energy released here. That will focus after radioactive decay. So let me come for radioactive decay. Now there's a pure mathematics. So I'll take a uranium, plutonium. So all these are what, like the substance which are